All right, good people. We are looking at a specific free response question from 2017. Now, this is on the A/B test, and I guess I can check, but in case we haven't discussed this in class explicitly, there are some shared problems on the A/B test and the BC test, and so there are some questions that both groups will see, even though their tests are taken separately. But there is some common questions. There are a set of common questions, and this could be one of them for sure. So we want to make sure that we understand how these work. And so Brian calls this rate in, rate out applications. And more we're starting to see in recent years the addition of these types of problems. So let's read the situation first, and then we'll kind of map things out and make sure we understand what's going on. When a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by f of t equals that function. So the very first thing we know is this is the rate of removal. Removal is this function. For times between 0 and 12, where f of t is measured in pounds per hour, and t is the number of hours after the store opens. So this goes up to 12 hours after the store is open. After the store has been open for 3 hours, the store employees start to add bananas to the display table at a rate modeled by g of t, given by this equation, for times between 3 and 12. Okay, so now we get adding bananas at a rate of this. So there's 50 pounds of bananas on a display. Customers come into the store, they start removing them and buying them at a rate of f of t. 3 hours into the opening of the store, I guess the employees see, people are buying bananas, so let's stock them with some more bananas. So they add more bananas to display at a rate of g of t. G of t is measured in pounds per hour. T is the number of hours after the store opened. Can you underline or highlight the important information from the above prompt? Complete the information below. Do we know the rate in? Do we know how much we're adding? And maybe I shouldn't say how much we're adding. Do we know how fast we're adding things? Well, we do. That would be this function, g of t. And the units of g of t are pounds per hour. So the rate of quantity going in, or the number of the rate at which bananas are being added to the display, is given by g of t. Do we know the initial amount? Well, yes, the initial amount is 50 pounds when it opens. So the initial amount is 50. And do we know the rate out? Well, yes, the rate out would be f of t, and that is also measured in pounds per hour. So therefore, could we write an equation to find the amount of bananas on display at any given time? Well, if we follow what we did in the previous videos, do we have a starting point? Well, we do. We have 50 pounds of bananas. But then we're going to add bananas coming in, and we're going to subtract bananas going out. So what we can say is we're just going to say we're going to add the change in from 0 to some time t of g of t, because that's how much they're coming in, the rate at which they're coming in, minus f of t, because that's the rate at which they're going out, dt. Now, in this particular case, I gotta be very careful, because remember, the rate at which they're adding bananas in, that doesn't start until 3 hours later. So I gotta be careful with that. So if I'm gonna do this equation, I have to make sure that t is greater than or equal to 3, because g of t doesn't exist until 3 hours in. Okay, what else do we know? Or what else do we want to know? How many pounds of bananas are removed from the display table during the first 2 hours the store is open? This is easy. Now wait, how do we know? Here's the question. How can we determine which functions to use? Well, it's talking about removal. and removal has to do with rate out. So in order to figure that out, we're going to do the integral in the first 2 hours, so from 0 to 2, of f of t, because f of t is the rate at which they're being removed, dt. If we do this integral, we'll figure out the total amount of bananas that are removed, because this is the rate at which bananas are being removed in the first 2 hours. Where is my equation, f of t? There it is. So I'm going to try to put it so that we can see it on the full screen here. And I'm going to use my little calculator here to figure things out. So let's clear this. We're just going to do an integral. Math 9. By the way, you should always use your calculator on these types of they don't want you to do a definite integral by hand. That would take forever. And if this is on the calculator part of the free response, which is the first two questions of your test, then by all means, please, please, please do the calculator. I'm going to type it in exactly the way I see it, which is 0.8, and I don't have a t, I have an x, and then sine. Oh, I don't know where the sign is, apparently. Let me go back, go back, go back, go back, go back, go back, go back. There you go. Sine of, and I'm going to do a little fraction here, t to the third, except I have x, over 100. And I think that is all I need. I guess I can close it. And so this set of parentheses is what's already created by the calculator. So I'm just putting exactly what I see here into my calculator, which is this part. Oh, this part right here. And then we're going to finish it out with a dx. And this should give me 20.051. 20.051. 20.051. Now, what did this represent? The pounds of bananas that have been removed in the first 2 hours. I answered question A. How? By using a definite integral, because when I take the integral of a rate, I get the change, in this case, the total change, the total amount removed of the original quantity, which is the amount of bananas. All right, let's see, what else do they want us to find? Can you find f, oh, this should be f prime. Can you find f prime of 7 and explain, using correct units, explain f prime of 7 in the context of the problem? Remember that the units for f of x was pounds per hour. Pounds per hour, which means the units for f prime, well, that's going to be pounds per hour, right? If we're taking the rate of the rate, then it's going to be whatever the rate is per hour. So pounds per hour, or pounds per hour squared. It says, on the calculator section of the free response, please do not compute the derivative by hand. Use the graphing calculator to find this equation. So we already know what the equation is. We're going to find the derivative of this, and we're going to find the derivative of this at 7. I think I already have the formula over here. So I can just say math 8. Oh, that's not math 8. Math 8. We're going to take the derivative. I'm sorry, my pen is not cooperating here. Of that function. Maybe it would have been a good idea for me to save this in y1. Then I could just bring it up as I needed it. Because otherwise I have to type this all over again and I'm wasting time, which is a luxury we don't have on the AP Calculus exam. But we want it at time 7. So we're going to 7, press enter, and you get negative 8.119. You can write negative 8.119, or you can round it to negative 8.120. I'm going to round it instead of truncate it. Truncate it means we're just chopping it off and writing the first 3 decimals. Rounding means I'm looking at the third decimal, looking at one more place over to the right. Is it 5 or more? Yes, and I'm going to add 1, and that's how I got negative 8.12. And that's what I'm going to say. So I'm going to say f prime of 7 is about negative 8.120. You could also say negative 8.119. Use the prompt below to interpret the meaning of f prime of 7 in the context of the problem. Okay. So what was f of t measuring? What was the original function, not the derivative? What was the original function f of t measuring? F of t was measuring the rate at which the bananas are removed, right? F of t was the rate that the customers remove bananas. So I can say the rate at which the bananas are removed is it increasing or decreasing? Well, I see that's a negative answer. So it's decreasing at a rate of, what is the actual number? 8.120. What are the units of the derivative? Well, we said the derivative of f was pounds per hour per hour. So I'm going to say pounds per hour at what moment in time did we use? At time 7. This is the format that you would use. This is the sentence stem, if you will, or the fill-in that you would use to interpret the derivative. The rate at which the bananas are removed is decreasing at a rate of 8.120 pounds per hour at time 7. That's it. You are done. Is the number of bananas on the display table increasing or decreasing at time 5? So by the time I get to hour number 5, the employees have already started to add more bananas. Customers are still taking away more bananas. So if I can figure out the rate at which the bananas are going out at time 5 and the rate at which bananas are coming in at time 5, then I can see, well, who's winning the battle? Are there more bananas coming in and going out? Because then it's increasing. Are there more bananas going out than going in? Well, then it's decreasing. But I need to figure out what the values are. So let's see. At f of 5 and g of 5. So let's go here. Remember, we just want f of 5. We don't want f prime of 5. We just want f of 5. So f of 5 would be, let me clear all this, that would be 10 plus parentheses 0.8 times 5 times the sine of 5 cubed over 100. What am I doing? I'm substituting a 5 wherever I see a t because we want time 5. And what we're going to get is the rate at which the bananas are being removed. Bananas are being removed at a rate of 13.7959. Okay. Now let's figure out what's the rate at which the bananas are being added. Well, for that, I'm going to need the g function. The g function was the rate at which the employees are adding the bananas. 3 plus 2.4 natural log of 5 squared, because this was time 5. What am I doing? 5 squared, and then plus 2 times 5, which is just 10, by the way. Close it. And that's going to give us this. All right, so how am I going to write this out? We just saw f of 5, 13.796 pounds per hour, lbs, and then g of 5 is 11.532 lbs per hour. So is the number of bananas on the display table increasing or decreasing at time 5? Well, this tells us that they're decreasing, or that they're being removed at a rate of 13.796. This tells me that they're being added at a rate of 11.532. So therefore, are they increasing or decreasing? Well, there's more, they're getting taken away at a faster rate than they are being added. So we're going to say the number of pounds of bananas is decreasing because f of 5 is greater than g of 5. That's one thing we could say. We could also say because the rate of removal is greater than, maybe this is the better way to say it, than the rate of addition of bananas. So the rate of removal, the rate at which bananas are being taken away, is bigger than the rate of addition, bananas being added to the display. So therefore, overall, the number of bananas are decreasing. Decreasing. And then finally, letter D. How many total pounds of bananas are on the display table at time 8? Well, how many did we start with? Well, we started with 50. But then they started to be taken away. So minus the integral from 0 to 8 of f of t dt. Remember, f of t is the rate of removal. But then they started to add it. Be careful, because they didn't add it right away. They didn't add it from the beginning. They started adding it at time 3. And from time 3 to time 8, now they added more bananas. And if you do this whole shebang, this is going to tell you how many total pounds of bananas are on the display at that specific moment in time, because we have the starting amount minus the integral of the rate of removal plus the integral of the rate of addition of bananas, and together that gives us the answer. And that's exactly what we need. Okay. Do we need to figure this out? Yeah, we need to figure this out. Let's figure this out. 50. We're going to start with 50 plus math 9. That gives us the integral. I'm sorry, not a plus, minus going from 0, because bananas started disappearing from the display case right away, of f of t. So that's 10 plus 0.8 x times the sine of x cubed over 100. Oh, too quick. Over 100. Close it, and then that would be dx. Also, I think I didn't erase the plus. I just put a minus. So I need to get rid of this. All right. And this should be 50, so I need to insert a 0. Okay. 50 minus this integral, because this is the rate of removal. And then we're going to add math 9 from 3 to 8 of, and now we do the other formula, 3 plus 2.4 times the natural log of x squared plus 2x. Close it. And we'll dx and press enter. 23.347. 23.347. Now, what is this measuring? Oh, total pounds of bananas are left on the display case, the display area where you hold the bananas at time 8. At time 8. We started with 50. They started to be, the customer started to take them away, starting from the beginning all the way to time 8. The employee saw that, so they started adding them once we got to hour 3. And from hour 3 to hour 8, they were adding more. And if you do all of that, bammo on your calculator, you're going to get the total amount of pounds of bananas that are on display at that moment in time. So the big idea here is we're going to look at some more free response questions where we have this rate in and rate out. It could be cars going into the garage and cars coming out of the garage. It could be water being pumped into a tank and water being drained out of the tank. This combination of rates, it has become a more popular part of the free response question, and a good way for them to test what you know about derivatives, about integrals, and how the integral of a rate will produce the net change of the original quantity. But we'll take a look at more of these in class.